Which of these is the wrong statement? If delta x of t is convolved with the delta of t, x of t itself, that is statement A is correct, true statement. Comes to, if x of t convolved with the shifted impulse, then the signal is also shifted by the same amount, and x of t minus lambda 1 convolved with del of t minus lambda 1 is nothing but x of t minus lambda 1 minus lambda 2. So statement D is the only wrong statement because all the three statements which E, B, C are correct. So option D is the false statement. Hence, option D is the correct.
Value of k for which the system is critically damped. Okay, we have to find the gain k for which the system is critically damped. Okay, he has given g of s and h of s is equal to k by, okay, I can write this one as g of s, h of s is equal to k by, what is this one? S into s plus 5 into s plus 10. So this is equal to s square plus 5s into s plus 10. Okay, now this is equal to s cube plus 15s square plus 50 into s. Now what is the characteristic equation? Characteristic equation is given as s cube plus 15s square plus 50s plus k is equal to 0. Okay, this is the characteristic equation. Now what is dk by ds? Dk by ds is equal to, we have to derive this k with respect to s. So this is d by ds times of minus s cube minus 15s square minus 50s. Okay, now where the value of zeta is equal to 1 be there in root locus. Okay, the only method is to find breakpoint in root locus at zeta equal to 1 is at breakpoint. Okay, that is at break-in point. If you see here the root locus plot, this is s equal to 0. Let us take, this is a point at s is equal to minus 5, and this is a point at s equal to minus 10, so on up to infinity. Now this is the branch which lies on root locus, and this will be the branch, another branch which is going to lie on root locus. Now zeta equal to 1, we have to find the value of k for which system is critically damped. That means value of k for which zeta equal to 1. Okay, it is zeta equal to 1 will be there only at breakpoints. Okay, you can remember this point at zeta equal to 1. That means we have to find at breakpoint. Now where can be the breakpoint? When two poles are, when two pole lies consecutively on root locus, then we can say that we have one breakpoint. Okay, how many number of asymptotes are possible here? Number of asymptotes are n minus m, that is number of poles minus number of zeros. Here we have 3 asymptotes. This pole 10, okay, this asymptote will be along this 180 degrees axis. You can also calculate plus or minus 180 by 2q plus 1 into 180 by n minus m. This will be the asymptote angles, which is equal to 60 degrees, 180 degrees and 300 degrees. That means we have a break away point here, since two poles are consecutively on the root locus. If two zeros are consecutively on the root locus, then we can say we have one break-in point. Here we have one breakaway point. That means now this breakaway point, that means these two poles will go along this breakaway point to meet asymptote at infinity, that is 0 at infinity. Now what is dk by ds? Dk by ds is given as 3 times of s square, derivative with respect to s, that characteristic equation. So this is minus 3 square minus 30s minus 50 is equal to 0. From this we can find that s is equal to minus 2.432 and minus 7.886. If you see here, minus 7.886 point, which lies between 5 and 10, this branch does not lies on root locus. That means we have to not consider this minus 7.886 point. So what is the value of s here? S is equal to minus 2.432 3 2. Now what is the value of k? K is equal to minus s into s plus 5 into s plus 10, or you can define as the value of k at s, this is at poles, divided by at zeros. Okay, since we don't have zeros, consider only denominator as 1. So what is the numerator part? Numerator part is equal to this one. So what is the k value here? K value will be approximately around 48. So option gain k is equal to 48 is the answer. Option B is correct answer. This table for k equal to, he has given a block diagram. Okay, in that diagram we have gain k. We have to find out when this gain k is stable. For what value of k it is going to be stable, the system. Okay, now what is the characteristic equation? We have to find. From that we can analyze the root locus, or we can also find Routh-Hurwitz criteria. It is better to find Routh-Hurwitz criteria, it will be easy. Okay, now what is the total block transfer function? Total block transfer function, if you reduce this one, okay, we will get it as k by s square plus 0.1 ks plus k. This is the overall transfer function of this block diagram. Okay, now what is the characteristic equation here? S square plus 0.1 times of ks plus k equal to 0. So this is closed loop transfer function. Okay, now what is Routh-Hurwitz criteria? From Routh-Hurwitz criteria we can find this one as s square s power 1, this is s power 0, alternate terms 1 and k, this is 0.1 k. So what is this one? This is equal to k. Okay, when the system is stable, when k is greater than 0, or you can say 0.1 k is greater than 0. Okay, or this is also, it is found as k is greater than 0. So only one condition it is there. When gain value is greater than 0, the system is stable. When gain value is equal to 0, then system is marginally stable. This one is stable. When gain value is less than 0, then this is unstable. Okay, these are the three conditions which is possible for the gain value of k. So answer option is A, since we have to find out the condition for stability. Okay. Response of the system is shown in figure if the pole zero plot is of the form. Okay, now he has given the four options and there are two poles in the left hand side. So okay, this is the real axis and this one is j omega axis. Now let us take this is minus sigma and the pole at these points is j omega. So what can I write this expression? Okay, I'm doing it here. What we can write that expression? These are imaginary poles having real part. Okay, so I can write this one as s minus or s plus sigma whole square plus omega square is equal to 0. These are the poles we are having. Okay, so what can I write from this? S1 comma S2 is equal to minus sigma plus j times of omega. Okay, or now this is the function. What we can write? The inverse Laplace transform of this one, j times of omega square. If this is the response we are having it. Now what is h of t here? H of t is equal to, I can write this one as e power minus sigma t into, okay, it is multiplied and divided by omega. So this is by omega into omega by square plus omega square is sine at, so sine omega t. So from this response what we can write this one, this is e power minus at. So these are damped oscillations, okay, or you can say decaying oscillations with respect to sine term. Okay, so this is not damping, this is not reducing to 0 at infinite, so this is not the option. Similarly he has given the other three options as like this. This is reaching infinite and infinity, so this is not the correct answer. So what about this option A here? We are having e power minus at function. E power minus at function response is a decaying one. We have a sine response. Okay, so what is the joint of these two response? What is the combined response of these two? Option A is the correct